To give you a sense about this, the elk ate so many aspen that you now see these small stands, as you see here, protected by a kind of a barrier to keep the animals out. The aspen were once very, very plentiful in Yellowstone. Now, when the aspen were consumed, the beaver left, because the beaver needed aspen to make dams. And they disappeared. Beaver are essential to the water management of the park. Without dams, the meadow dried hard in summer, and still more animals vanished. The situation worsened. It became increasingly inconvenient that all the predators had been killed off by 1930. So in the 1960s, there was a sigh of relief when new sightings by rangers suggested that wolves were returning. There were also persistent rumors that the rangers were trucking them in. But in any case, the wolves of the 1960s vanished soon after. They needed to eat beaver and other small rodents, and those animals were gone. Pretty soon, the Park Service initiated a PR campaign to prove that excessive elk were not responsible for the problems in the park, even though they were. The campaign went on for about a decade, during which time the bighorn sheep virtually disappeared. Now we're in the 1970s, and bears were starting to be recognized as a growing problem. They used to be considered fun-loving creatures, and their close association with human beings was encouraged within the park. Here's a bear feeding where people used to come and watch them. And I think this still went on. I think I saw this as a kid in the 1950s. Here's a postcard from the 1930s. How things were in Yellowstone, setting the table for bears at Lake Camp, Yellowstone Park. You see, they have very good table manners. But now it seemed that there were more bears and certainly many more lawyers in the United States, and thus more threat of litigation. So the rangers moved the grizzlies away. The grizzlies promptly became endangered. Their formerly growing numbers shrank. Park Service refused to let scientists study them, but once the grizzlies were declared endangered, then the scientists could go in and study them. And by now, we're about ready to reap the rewards of our 40-year policy of fire suppression, Smokey the Bear, and all of that. The Indians used to burn forest regularly, and lightning caused natural fires every year. But when these are suppressed, branches drop off trees to the ground over the years, and that makes for a very hot, low fire that sterilizes the soil. And in 1988, Yellowstone burned. In all, 1.2 million acres were scorched, and 800,000 acres, 1/3 of the park, burned. Then, having killed all the wolves, having tried to sneak them back in, they officially brought the wolves back, and now the local ranchers screamed. But the wolves seemed to be eating enough of the elk so that slowly the ecology of the park was being restored. Or so it was claimed, as it had been claimed before. And on and on and on. As the story unfolds, it becomes impossible to overlook the cold truth that when it comes to managing 2.2 million acres of wilderness, nobody since the Indians has had the faintest idea how to do it. And nobody asked the Indians, because the Indians managed the land very aggressively and very intrusively. The Indians started fires regularly. They burned trees and grasses. They hunted the large animals, elk and moose, to the edge of extinction in the Yellowstone, which was the hunting ground of a number of tribes. These are Shoshone. White men refused to do that, and they made things worse. To solve our embarrassment, everybody pretended that the Indians had never altered the landscape. Quite the contrary, these pioneer ecologists, as Stuart Udall called them, did not manipulate the land, we were told. But now academic opinion is shifting again, and the wisdom of Indian land management policies is being discovered anew. Now, if we're going to do better in this new century, what must we do differently? In a word, I want to say we must embrace, it's not a word, but it's a phrase, we must embrace complexity theory. We must understand complex systems. We live in a world of complex systems. The environment is a complex system. The government is a complex system. Financial markets are complex systems. The human mind is a complex system. Most minds, at least. By a complex system, I mean one in which the elements of the system interact among themselves such that any modification we make to the system will produce results that we cannot predict in advance. Furthermore, a complex system is sensitive to initial conditions. You can get one result from it on one day, but the identical interaction the next day will yield a different result. We cannot know with any certainty how the system will respond. Third, when we do something to a complex system, we may get downstream consequences that emerge weeks or even years later. We must be watchful of delayed and untoward consequences. The science that underlies our understanding of complex systems is now 30 years old. A third of a century is plenty of time for this knowledge to filter down to everyday consciousness. But except for slogans like the butterfly flapping its wings and causing a hurricane halfway around the world, not much has really penetrated general human thinking. On the other hand, complexity theory has raced through the financial world. It has been briskly incorporated into medicine. But organizations that care about the environment do not seem to notice that their administrations are deleterious in many cases. Lawmakers do not seem to notice when their laws have unexpected consequences. Governors and mayors and managers may manage their complex systems well or badly. But if they manage well, it is usually because they have an instinctive sense of how to deal with complex systems. Other managers fail. Why? Our human predisposition is to treat all systems as linear when they're not. A linear system is a rocket ship flying to Mars, or a cannonball fired from a cannon. Its behavior is quite easily described mathematically. A complex system is water gurgling over rocks, or air flowing over a bird's wing. The mathematics are complicated, and in fact, no understanding of these systems was possible at all until the widespread availability of computers. One complex system that most people have dealt with is a child. If so, you've probably experienced that when you give the child an instruction, you can't be certain what the response will be. This is especially true if the child is a teenager. One day they may do as they're told, the next day they will leave the house. Run away, join the circus, or whatever it is that they do now. And similarly, you can't be sure that an identical interaction on another day won't have spectacularly different outcomes. If you have a teenager, or if you invest in the stock market, you know that a complex system cannot be controlled. It can only be managed. Because the behavior cannot be predicted, it can only be observed and responded to. The system may resist attempts to change its state. It may show resiliency or fragility. But a very important feature of complex systems is that we don't know how they work. We don't understand them. We just interact with them. Whenever we think we understand them, we learn that we don't, sometimes spectacularly. What then happened in Yellowstone? My answer is people thought they understood the system. They were wrong. Let's look back to the 1970s, the Club of Rome's volume Limits of Growth. It has this slide, I've left it yellowing to show age. It has this chart to explain what regulates fertility, which is agreeably simple. The problem is this: in 1995, my classmate Joel Cohen said most professional demographers no longer believe they can predict precisely the future growth rate, size, composition, and spatial distribution of populations. Here's another chart from the Club of Rome, which it's one of my favorite because you see it doesn't really have axes that are labeled in any way. It's just a kind of diagram of what might happen or what the computer run suggested in one point. It's a picture. And here's another one of those feedback loops of population, capital, services, and resources, and so on. Now, The point is, this is highly simplified thinking, and it goes on to this day. Here's a modern chart from a modern sustainability website. It shows the relationships of pretty much everything. Lithosphere, biosphere, market, community, customers, everything. Again, agreeably simple. Who makes a chart like this? Who thinks the world operates in the least like this? Because it doesn't explain the world. One side of this equation is not the other. And in truth, what I want to show you is that this chart, and there's gazillions of these kinds of charts in environmental literature, this chart is absurdly simple. For example, here's a more complex chart which shows the wiring diagram of the stomach of the lobster. Quite a bit more complicated.